Everyone. Today we have the question number as 1292, in which what we have to do is we have to find the maximum length of a square whose sum is less than or equal to a given threshold value. So in this we are given a matrix and an integer threshold, and we have to return the maximum side length of a square whose sum is less than or equal to that threshold. So we will see this with an example. Suppose we are given this matrix and the threshold is 4. So we have to return a square such that the sum of all its elements should be less than or equal to 4. So it is shown that the this one square, the one highlighted with the red block, is one of the possible answer, and the one with the yellow block is one of the possible answer, and the constraints, the number of rows and the number of columns can be in between 1 to 300. Okay, so what will be our approach for this question is, first one, like brute force, try all possible. So what we can do is we can try all possible squares of different sizes, and once we get our answer we will stop. So but the thing is that the total number of squares possible is like, uh, if suppose m is 300, n is 300, and the minimum is also 300, so it will become too slow. So how can we make it faster? So to make it faster, we will be using two different concepts here, and like these are two very important concept. One is prefix sum of the grid. So this will make our sum calculation very much faster, and the other is like binary search. So on what we apply the binary search? So we will be applying binary search on the side length possible of the square. So suppose like we have a side length from 1 to 300. So first we will check for 150. If it is possible for 150, then we will go for higher, else we will go for the lower side lengths. So this way we will be using these two concepts here. So the thing is, how do we calculate some prefix sum here? Like suppose, so first of all we will take a matrix size of m plus 1 cross n plus 1, and what prefix sum at point I comma j denotes, it denotes that the suppose we will make a rectangle from 0 comma 0 to I minus 1 comma j minus 1. So sum of all the elements in that rectangle will be stored at prefix of I comma j. And next like we will be using this formula. So I'll be explaining how we are getting this formula, like prefix of I comma j. So for that, like, take this we'll be taking this matrix, and suppose we have to calculate prefix of so suppose we have to calculate a prefix of 3 comma 4, which is the rectangle from 0 comma 0 to 2 comma 3. I'll show you by drawing this one. uh, yeah, so this will be the this rectangle, right? So how can we calculate the sum of all elements in this rectangle? So for that, like we have already computed the sum of this rectangle previously, right? S- this rectangle, and we also have the sum of this rectangle. These two rectangles are previously computed with us, right? This one and this one. So we will be using these two rectangles to calculate the sum of this bigger one rectangle. So if you can see, this rectangle plus this rectangle and minus the one that overlapping area, like this area is coming in both the rectangles, so we'll be subtracting that, and this element, that is matrix of I minus 1 comma j minus 1. So these four things are helping us to calculate the sum of all the elements of this bigger one. I'll show you once again. So to calculate the sum of all the elements of this rectangle, Instead of iterating, what we will do is we have calculated already this one, and we also have calculated this one. And see, in these two, if we'll add both these two, this part is common, means adding two times, so we have to subtract this part, and also we need this element, so this way. So if you'll see this formula, prefix of 3 comma 4 is equal to matrix of 2 comma 3, that is this element, plus prefix of uh, 2 comma 4, 2 comma 4, that is this one, plus prefix of uh, 3 comma 3, that is this, the sum of all these elements minus the common elements. So this way we'll get the prefix matrix. So once we calculate the prefix and matrix using the above formula, and I have shown you with an example how this formula is calculating the sum. So once we get all the formulas, what we will do is we will apply binary search on the side of square. So suppose here number of rows is 3 and number of columns are 7. So maximum side square that we can achieve is minimum of rows and columns. So maximum we can get is 3, and minimum side square we can get is 1. So we'll apply binary search on the side of square. And suppose at some point we are trying to get a square of side k. So if we'll get some answer for that side, we'll try for sides from k to maximum. And if for k it is not possible, then we'll try for sides lesser than k. So it's basically we are applying binary search on the square of side. Next, how we will check that a k side square is possible or not? Like, so for that we have to find the sum of that k side square, right? And how, next question is like how we will find the sum of that k side square. So for that, like, we have this formula, and I'll be explaining you how this formula is working, right? So suppose we have to find we are given a point. Suppose I is equal to 0 and j is equal to 1. Suppose we are at point this one, and we have to find the sum of this is the sum of this square. So how we will be finding it using the matrix that we have calculated, right? Let's check that out. So if we will take 0 plus 3 and 1 plus 3, what prefix of 3 comma 4 will give us? It will give us the sum of the rectangle from 0 comma 0 to uh, 2 comma 3, that is, it will give us the sum of this area 0 comma 0 to. So prefix of this value will give us the this sum, right? But but we need only this one, so we have to subtract the extra sum that we have calculated, right? So for that, like, we will be minus subtracting this part. So prefix of 0 comma 4, 0 comma 4 will be 0 only. If you'll see in the prefix matrix, if you'll see in the prefix matrix, so all the 0 rows and 0 columns value is 0 only. So this one will be giving us 0 minus prefix of 3 comma 1. 3 comma 1, what it will give us? So it will give us the sum of the rectangle from 2 to 0 and 2 to 0, which is this rectangle. That is the extra one that we are counting, 2 to 1. So we'll be subtracting this from this, so we'll, and then we have prefix of 0 comma 1. What prefix of 0 comma 1 will give us? here it is giving us uh, array yaar, 0 only. So if we'll see in the matrix, this value is giving us the sum of this uh, matrix, and this one is giving 0, and then this third part is giving the sum of these values. So if from the whole we will be subtracting this part, we are getting the sum of this square, right? So we get our desired sum. So once we get our sum, we will check whether that sum is less than or equal to threshold. So if it is less than equal to threshold, means that square is possible, so we will be returning true in that case. And if it is not possible, then we will go to next point and then check the that at that point that sum of size k is possible or not. If if and if we will check at each and every point, and if none of the case size is possible, then we will reduce the side using that binary search. We will be minimizing our our search space. Next we will be seeing the code. So first of all, we will be making a prefix sum matrix. So prefix sum of, declared a vector, and then using two loops and using the formula, we will be computing the prefix some matrix. After prefix some matrix, we'll be taking the low pointer and high pointer and answer to store the side, and then apply the binary search. So we will be computing the midpoint and checking if the midpoint, that square of side equal to mid, is possible or not. If it is possible, suppose if this will return true, means the answer is possible, so we will be making the answer is equal to mid, and then shifting our low pointer to the mid plus 1. Suppose mid is possible, so means if mid is possible, then we will be checking for max, we want maximum answer, so we will be checking for higher values, so we will be checking for mid plus 1. And suppose if at mid we don't get a square of side k, then we have to check in the smaller values, so we will be shifting the high pointer. And how to check if k size square is possible or not? So for this, we'll be using two loops and finding the sum of the square, and if sum is less than threshold, means it is possible, then we will return true. And if after checking of all the points there is not a single square we get, then in that case we will be returning false. That's it. Thank you. If you like the solution, please make sure to share and subscribe. Thank you.